Ben, I don't get this whole physics thing.
I'll teach you.
How could you possibly teach me, Ben?
Well, you like sports, right?
Yeah, but is there physics in sports?
Of course. I'll show you. Meet me at the baseball field tomorrow at 8 o'clock in the morning.
Good morning, Spencer. I'm glad you met me out here.
No problem, Ben. I'm just excited to learn some physics.
Well, Spencer, let's first talk about projectile motion, one of the most basic concepts in physics. So, I'm going to use a baseball as an example. So, when the baseball leaves your hand as you throw it, it has a constant velocity in the horizontal direction, right? As we know from Newton's first law, an object in motion will stay in motion unless acted upon by an outside net force, and air resistance doesn't provide much of an outside net force, so basically it is a constant velocity in the horizontal direction. However, it has acceleration in the vertical direction because the Earth is always pulling the ball towards it with a force of 9.8 meters per second. Therefore, it's always accelerating towards the Earth. So, as you can see, with acceleration in the vertical direction and a constant velocity in the horizontal direction, it makes a path such as this.
Wow, Ben, that's really cool. Does that work with all objects?
Why, yes it does, Spencer. Let me ask you this. Do you ever strike out in baseball?
Yeah.
I thought so. And do you ever get really mad and throw your bat when you strike out?
I'm sure I have once or twice.
Okay, well, next time you throw your bat, watch as you throw it, because the center of rotation of the bat, as it rotates, the center of rotation follows the same projectile path that a ball does.
Oh, sweet. Let me try. Ben, it worked.
Alright, Spencer, let's head to the field. I'm going to show you another example of physics in sports.
Alright, Ben, now that we're at the soccer field, what kind of physics can I learn?
Well, let's see what we can find.
Well, oh, there's a soccer ball over here. What can we do with this?
Well, let's see what happens when we kick the ball around.
Alright, here we go. There we go. Hey, Ben!
Well, Spencer, now that we've had our fun, let's talk about the physics of kicking a soccer ball.
Well, I remember reading about elastic collisions. Does that have to do with soccer?
Most definitely. Do you know the equation for an elastic collision?
Isn't it something like mass 1 times velocity 1 plus mass 2 times velocity 2 equals mass 1 times velocity 1 plus mass 2 times velocity 2?
Precisely. But let me show you what that really means. Well, Spencer, basically what that means is the momentum before the collision is the same as the momentum after the collision. And as we've learned, momentum is equal to mass times velocity. And so we know that the mass times velocity of my foot plus the mass times the velocity of the ball before the collision is the same as the mass times the velocity of my foot and the mass times the velocity of the ball after the collision.
That's crazy, Ben. I had no idea that my foot before the collision has the same momentum of the ball after the collision.
I think I have time for a few more examples. Follow me. Tell me, Spencer, do you like to play golf?
Yeah, on occasions.
Well, what do you picture when you think about playing golf?
Well, I picture the club hitting the ball.
Well, that's funny because I picture the ball hitting the club.
What do you mean, Ben? I'm clearly hitting the ball.
Well, Spencer, to understand this, you have to understand Newton's third law. Newton's third law states that every action has an equal and opposite reaction. Therefore, that's why when I hit the golf ball, I hit the golf ball with the same amount of force that the golf ball hits the club.
So you're telling me that not only is the club hitting the ball, but the ball's hitting the club?
Exactly. Come on, I got some more stuff to show you.
Ben, what are we doing at the tennis courts?
Well, Spencer, I wanted to use tennis as an example for one of the most important laws in physics, Newton's second law.
I think I remember learning about that. Isn't it like force equals mass times acceleration?
Yes, it is. Let me show you what that means. Well, Spencer, do you ever wonder why a tennis ball goes farther than, let's say, a soccer ball? I used the same amount of force to hit both those balls, but the tennis ball went a lot farther. That's because it has less mass. We know the equation for Newton's second law is force equals mass times acceleration. And I used the same force to hit both balls, so that means the mass times acceleration of the tennis ball is the same as the mass times acceleration of the soccer ball. Because the soccer ball has more mass, therefore it has lower acceleration.
Well, Ben, I had no idea there's so much physics in sports.
Well, I sure am glad I could help you out today, Spencer. I hope you learned a lot.
Yeah, I sure did learn a lot today, Ben. Thanks for the help.